Hello friends. In our earlier example, we discussed about the synchronized method, right? Now let's make this session a little bit more interesting. What would be the thread's behavior or what would be the application behavior if an object has two synchronized methods? How that's going to behave, right? That's what we're going to discuss in this session, okay? So let me share my screen. Okay, to facilitate this discussion, I put together yet another boyfriend and girlfriend demo example, right? And friends, if you haven't watched our earlier video on the Java synchronized method, I highly recommend you to watch that first before coming and watching this video, okay? Let's discuss about it, okay? Okay. So friends, this is the behavior. This is the example we have put together. See, this has this class called same object sync demo. Here is the main method, the entry point. It has two threads, boyfriend thread 1 and then a boyfriend 2. These are two threads, and here we are launching them concurrently at the same point in time. Let's look at what they are doing. See, this boyfriend 1 thread is invoking the sing method. That is asking its girlfriend to sing. And then this boyfriend thread 2, right? It is asking that same girlfriend object to count, right? So it is the same girlfriend object, but there are two boyfriend threads. Each one is trying to invoke two different methods on the girlfriend object. Okay. So let's look at this one. Let's look at what is the sing. This is the girlfriend object. What does the sing and what does the count do? If you see the sing method, it just just printing a lullaby, right? It's just printing a text, right? It's trying to sing. And then I'm putting this thread to sleep for 100 milliseconds, so that the reason is I can take some diagnostic information when this program is executed, so that which is needed for our discussion. So it's trying to print this lullaby string for 10 times, right? It's going on a loop and printing for 10 times. Before every print, it's going to sleep, right? And let's see what this count method does. So the count method is basically going on a loop and it's printing from 1 to 10. And then similarly, it is also sleeping for 100 milliseconds, right? Nothing complex, very, very trivial. So when I'm going to execute this method, what's going to happen? Does anyone want to say? When I'm going to execute this method, what's going to happen?
It will print both messages.
Correct. So here, let me run this program. Okay. See, when we execute it, you can see, because there are two threads coming, they're trying to invoke the same girlfriend object. Here, first time it's printing lullaby, right? The sing method output, and then the one lullaby, right? It's getting mixed up. That is, when the girlfriend is singing, it's trying to count, right? Because two threads are acting on it at the same time. Oh, lullaby one, and it's trying to sing count, right? It is going to be confusing for the girlfriend object. So now what we will do, we will help this girlfriend so that it can stay focused, right? It can just do one thing at a time. So to do this, I'm going to let's make this method as synchronized. Right? I made this method as synchronized. And then I'm making this method also as synchronized. When I do this, let's now execute this object. Let's execute this program. Okay. And let's execute this. Okay. Look what has happened. It has printed lullaby. It first completed the sing method. It completed the complete sing method. And then only it started to do the count. Because when the first boyfriend thread one, it came, it was executing this one, and then it went on to execute this one, right? So what happens under the scene? What happens? How Java enforces this, right? So friends, what happens is when a method is synchronized, as we saw in our earlier video, right? When boyfriend thread 1 comes and execute this sing method, it would have already acquired the lock of this girlfriend object. It already acquired the lock of this girlfriend object. So when this boyfriend thread 1 is asked this lock, the JVM will not allow any other threads to enter any other synchronized method in this object. See, the count is now a synchronized method, right? So if it tries to come, and then when it goes, it will not be allowed. So it has to wait. So now this boyfriend thread will be put into the blocked state, right? So only after this completes. So that's why we are seeing the lullaby to be printed. After that, we go on to print 1 to 10. Right? Is this making sense? Any questions so far?
No.
Okay. Okay. Thank you. Feel free to bring up any questions at any point in time. Okay. So now let's see what happens under the hood. Now let's go. How does a JVM executes this program, right? How does a thread behave? All those things we'll start to look. So to do that, when this program was running, I executed a yCrash, the open source script, which captures a 360-degree data about your entire technology stack. And then from that, I took a thread dump and then I analyzed it with the fast thread tool, which is a thread dump analysis tool. Let's look at that thread dump analysis report, what it's showing. Okay, friends, even before going in there, I want to show this. I want to explain this. See, this is what it happens, right? This diagram tries to illustrate what I was talking so far. So here there is this girlfriend object, right? Now the boyfriend one, it came and it started executing the sing method, which is a synchronized method. So it acquired the lock and it was executing. Well, while this boyfriend thread was executing, when boyfriend thread 2 comes, when it tries to invoke the count method, it won't be allowed to execute it. It won't be allowed to enter because this boyfriend thread would already acquired the lock. So that's why this boyfriend thread is not allowed to enter. So now let's look at this thread dump report. Okay. Now it has this thread, this analysis report has multiple sections. Now, if you see, there's one interesting thing is happening. It's showing one thread is in blocked state. If you want, I can click and see what is this thread. So this is the thread, right? Which is that boyfriend thread 2, which is being blocked. Now let's look at it as more interesting things. Let's look at it. Now I'm coming down. Okay. Here, whenever the threads get blocked, the tool presents a transitive dependency graph. So here it's showing a transitive dependency graph. Here it is saying this girlfriend object is blocking one thread. And here is that graph it is showing. Here you can see it's showing this boyfriend thread 2 is being blocked by this boyfriend 1, right? Now let me click on this one. When I click here, I'm able to see the stack trace. Here you can see this thread launched, boyfriend 2 run. And then after that, it went on to try to execute the count method. See, the boyfriend 2 was trying to execute the count method, but it wasn't allowed to enter because the boyfriend 1 has acquired the lock. And you can see this thread is now saying waiting to lock. And it is waiting to lock on this girlfriend object. And each, as I told in the earlier video, each and every object has an object ID. So here it says this thread is trying to acquire the lock of this object, whose object ID is this. Note down this number. It ends with FE0, right? So due to this thread is in now blocked state. Now let's go back. So this is the guy who is blocking our boyfriend 2. Now let's look at this. What is his boyfriend 1's stack trace, right? Now, when we come in here it started out, there is this, it started out here, the run method. And then here it went on to execute the sing method, right? That this boyfriend 1 is the one who is invoking the sing method. But you see here, this statement is very, very important. It says it has locked this object, girlfriend object. It has acquired the lock of this girlfriend object, the same object for which the boyfriend thread 2 is waiting. Now, after acquiring a lock, it executed it. In this case, we just put it to sleep, right? That's why it's showing us to sleep, right? So this is what happens under the hood. How does the lock behaves, right? Any questions, friends, on this explanation?
No.
Okay.
No.
Okay. Good. So, okay. So friends, even though the synchronized method, you understand what's going on, but you want to use it with care, right? It has a lot of, you can see it's going to lock all the threads which is going to come in. So you want to execute, you want to make a method synchronized. Only if you know you don't want to let multiple threads come and execute it at the same point in time. Otherwise, it will have a significant performance hit because what is a thread at the end of the day? Thread is nothing but a customer request. It's basically a customer, right? It's a customer request coming in. If multiple threads comes in, that means multiple customers are coming in. And if you make a method as synchronized, then they're all going to wait. It's going to degrade your response time. So we want to use the synchronized method one with extreme care. Okay. Thank you, friends. We'll look forward to meet you with at another interesting session. Thank you.